Okay, so in the last video, we were talking about these systems of equations, so solving two or more equations. So we did this first example and the second example that we're just going from numbers to our equations and then solving them. Then we had an example of this family going to the movies. We had adult tickets, we had children's tickets, we had a total of number of people, and we had a total value of what they paid. So we did that one. So these, a plus c equals 8 and 11a plus 8c equals 73. Those were our two equations that we wrote. And then we solved them using our substitution method. Okay, so let's go ahead and try another few problems here. So we have the length of a rectangle is 4 inches longer than the width. If the perimeter of the rectangle is 36 inches, find the dimensions of the rectangle. So again, we need to start out by knowing what we're being asked to find. We're being asked to find the dimensions of the rectangle. In other words, the dimensions mean the length and the width. Okay, that's what that means. So those are the two things I'm looking for. So those are going to be my equations. Now, you could do this in two different ways, okay? I'm going to write it out first as using two variables. You can actually do this one also just using one variable. So I'll show you both ways. So if I'm thinking of these two as my two unknowns, I need to find the length of the rectangle and the width of the rectangle. So I can use X and Y, or I can use L and W, whichever you like. If I use L, I'm going to use a capital L because a lowercase l looks like a 1. Okay, so now then we know what we're looking for, and we're going to use the information in the problem to write our equations. So the length of a rectangle is 4 inches longer than the width. So by now, this should seem pretty familiar to you, right? That kind of statement. So that is going to say the length is 4 inches longer than the width. So the length is 4 longer than means 4 more than, right, the width. So if the width, let's just say we're 25, then the length would be 4 more than that, 4 longer would be 29. So that's the relationship there. Okay, now we have another sentence here that gives us another relationship. So it says, if the perimeter of the rectangle is 36 inches, find the dimensions. So the other piece of information we know is that the perimeter of the rectangle is 36 inches. Well, that only helps us if we know how that relates to what else we know. If we just put P equals 36, that doesn't really help us because we need a second equation that has L and W in it to get those solved. So think for a minute about the perimeter of a rectangle. The perimeter of any shape is just adding up all the sides of that shape. Okay. So if this is my length or my width, I don't know, we can call it either way. Let's call that the width and this the length. Then we know that this is also the length and this is also the width. So if I want to find the perimeter of a shape, I start at one spot and I go all the way around that shape like I'm a little bug walking around it. So my perimeter here would be a width plus a length plus a width on the top plus a length down the side. So bottom, right side, top, left side. So this is what the perimeter is. Well, if you look at this, I can combine like terms. So I get 2W plus 2L. Right? W plus W is 2W, L plus L is 2L. Sometimes you will also see it 2 times W plus L. If you think about going from this third line up to the second line, think about what we would do. We would distribute, and that's what you get there. And the opposite of doing that is called factoring. We will learn about that in Chapter 9. So you could have either of those second two be your perimeter formula. Okay, so I'm getting somewhere closer, right? I'm going to use this one. I'm getting closer because W and L are both in this equation now. And if I think about what I know that the perimeter is 36 inches. So my perimeter is 36. That can go in for P. And then I will just have an equation that has W and L again. So we're going to say P equals 2W plus 2L. Okay, so we have, oops, you know what? I didn't want to do that, did I? Instead of P, I want to put 36 in there. Sorry. Okay, so 36 equals 2W plus 2L. So we don't know what W and L are yet, but we know that when we add two W's, the top and the bottom, and two L's, the sides, that adds up to 36. And if we look at our equation here, the top equation, we can see that it is set up for substitution. So there's my length, it equals 4 plus W. That means that those two things can be interchangeable. So I'm going to plug in, I'm going to substitute 4 plus W in place of that L. And we saw one in class, I think in both classes, where we had to do this before, where we're substituting in more than one term that's going to be multiplied by something. I want 2 times 4 plus W, so that 4 plus W is going to be in parentheses. So I take this bottom equation, I rewrite it, so 36 equals 2W plus 2. Now in place of L, I write 4 plus W. Okay, so I'm going to just shade that in just to remind us that's the part that got substituted. Okay, now, again, when I'm here at this last step that I just did, the good thing about this is I only have, oops, I keep trying to do that right with my highlighter. I only have one variable. Now I can solve this. So I solve it for W. So I have 36 equals 2W plus, I'm going to distribute this, so I get 8 plus 2W. So I can combine on the right-hand side. 2W plus 2W is 4W. And then I'm going to subtract 8 from both sides. So let's see, 36 minus 8 would be 28 equals 4W. I'm just going to rewrite this over here so I have some more space. And I want W by itself, so I divide, and I get that W is 7. Okay. Now, at the end of any problem, no matter what kind of problem you're doing, it's always good to make sure you remember what it was. Like 7 what was my context? Well, if we go back, we're talking about this rectangle, right? So this W is 7 inches. All right, now let's go back to think about our rectangle for a minute. So we know the width now. Now we need to know the length. So again, to find the missing variable, I just use either equation. So I am going to use the top equation just because it's a little bit simpler, right? Just because L and W don't have coefficients. So L equals 4 plus, well, W is 7. So L is going to be 11 inches. And then, as we talked about, you always want to go back and check it with the problem, with the words. So the length is 4 inches longer than the width. Yes, that is true because the length is 11 and the width is 7. The perimeter is 36 inches. Okay, well, if I have my rectangle, okay, I was calling this the width, so my width and length are kind of swapped in terms of size, but so let me redraw this a little bit more accurately. We'll do it this way. How's that? So this is my width. This is 7. And this is my length. This is 11. Well, I know this is going to be 11, and this is going to be 7. And 7 plus 11 is 18. And another 7 is 25. And another 11 is 36. So yes, that perimeter is 36 inches. And you can also put your answers up here if you want. Just make sure that they're clearly labeled one way or another, which is which. I can't just have, 7 inches and 11 inches and not know which is the width and which is the length, okay? All right, so as always with these, I know you're probably sick of hearing me say this, but as always, make sure that you know how to do this on your own, okay? So as you're going through the video, you might get stuck a little bit, and then when you watch the video, it makes sense, or you might just be kind of following along right now. But you really need to make sure that you can do all of these completely on your own also. So after you're done with the video, you can look at the blank notes again and kind of try going through those again. Make sure that you understand every single step. All right, Tom has only pennies and nickels in a jar. If there are 83 coins and they total $2.95, how many of each coin is there? So again, here's my question. How many of each coin is there? Okay. The coins we have are pennies and nickels. So those are the two things I'm looking for. How many pennies and how many nickels, right? So let the number of pennies, and again, you can use whatever variable you want. Let number of pennies equal P. Let number of nickels equal N. Okay. All right. So what I'm going to do is I'm going to have you try to do this on your own. Okay. I'd like you to pause the video, try to write your two equations, and then solve them. The solving probably is the easiest part for you now, right? Because we've done it so much. So here are the things I will give you as little hints. So there are two sentences here, but it's a little different. We're not going to get one equation from the first sentence and another equation from the second sentence, okay? It's kind of condensed together. So the first sentence tells us very helpfully that we only have pennies and nickels. So basically that tells us we only have two unknowns, because if we had pennies, nickels, dimes, and quarters, we'd have four unknowns, right? So we only have two unknowns. So there are 83 coins. That's going to be part involved in writing one equation. And they total $2.95. That's going to be involved in another equation. Okay, so that's kind of your clue there. If it helps you, remember there's also the chart method. So you can also fill out our little chart, and that may help you write these equations too. It's totally not required, but some people like it. So this first column is going to be just pennies, nickels, and total. Okay, and then my columns are the number of each, the value of each, and the total value. Okay, so we already know the number of each. That's what our P and our N are thinking about. So, and I will tell you that when you use the chart like this, in this case, your two equations are going to come from here and here. Okay, so if it helps you to fill in that chart, you can go ahead and do that. All right, so go ahead and pause the video, please. See what you can do on your own, okay? Just sitting and watching it without trying it is not going to help you do it on your own. So go ahead and pause the video, try to write your two equations, solve them, and then come back. Okay, so we're back. Hopefully you have something on your paper there. You paused it and put some time into it. So we said in green here there are 83 coins. Now that is just telling me how many coins there are. It does not take into account the value of those coins, right? It doesn't matter if it's a penny or a nickel. We're just counting objects. So however many pennies and nickels there are, that has to add up to 83. If we want to put it on our chart, we can do that also. And then this gives us one of our equations, which is that the number of pennies plus the number of nickels has to be 83. There are 83 coins altogether. Okay, now let's look at the chart for a minute. Let's look at the value of each column. So value of a penny. Well, now we're talking about moving toward this yellow part where it says they total $2.95. So we need to know how much each one is worth. Well, a penny is worth 1 cent, okay? Because my total here is given in dollars, like 2.95, not 295 cents, we want to do the same thing here. So I'm going to say my penny is 0.01, right? 1 cent, or technically what that's saying is it's 1/100th of a dollar. But that's my value of my penny, And similarly, my value of my nickel is 5 cents. So I'm not writing it just as the number 5 because it has to match up with the format of the total. So the total value, again, if I have, for every penny I have, it's going to be 1 cent, right? So if I had 3 pennies, it would be 3 cents, 3 times 1 cent. If I had 6 pennies, it's 6 times 1 cent. Well, don't know how many pennies I have, but I know that no matter how many I have, it's 1 cent times P that will give me my total value for that pile of pennies. Then I move over and I have a pile of nickels. Well, however many there are, which is N, every single one is 5 cents, so 0.05 N. And then my total value, if I add up that pile of pennies and the pile of nickels all together, I'm going to get that total, which is $2.95. So that is going to be my other equation. And again, you don't have to use this chart method. You might have just kind of figured that out on your own. So it's going to be 0.01p plus 0.05n equals $2.95. Okay, so again, very similar to that movie question where we had adult tickets and children's tickets. It's, this is going to be pennies and nickels, but it's still how much something costs or is worth times how many there are. Okay, so now we can solve these. So we notice again that right now we do not have an equation that is solved for one of the variables, but this top equation is pretty easy to move things around. I'm just going to rewrite it here because it does not have coefficients in front of the p and the n. So let's just say I'm going to get p by itself. So I'm going to subtract n. P equals 83 minus n. Now it really does not matter which one you get by itself. I could have subtracted p, had n equals 83 minus p, that's fine. I would have just substituted in for the opposite variable at that point. Okay, so here's my equation saying that p is exactly the same as 83 minus n. Okay, they're exactly the same. So what can I do? Well, in the other equation, I can take out this p and I can replace it with 83 minus n. And again, because I have more than one term that's going to be multiplied by something, by that 0.01, I have to put that in parentheses. So I will have keep doing that again. Move back to my pen. 0.01 instead of p, I put 83 minus n. Okay, again, just using the color coding to kind of remind you that this is all, everything in pink is what is the substitution. And, if that helps you, feel free to do that on your paper, for the homework and the test also. And if it doesn't help you, that's totally fine. You don't have to do it. Okay, so 0.01 instead of p, I put 83 minus n, and then 0.05 n equals 295. Again, right at this point, we are down to one variable, which is good because then I can solve it. So I multiply, I distribute here. Okay, so when we distribute here, we have 0.01 times 83, and we're going to get 0.83. Now, think about that for a second. Don't get all confused about the decimals. But think about 0.01 as a penny or as 1 cent. If I have 83 pennies, I have 83 cents. Okay, now I'm going to have 0.01 n. It's minus, it's negative because I have a positive times a negative here. Plus 0.05 n. Then I can go ahead and combine like terms, which are my n terms. And then I'm going to subtract 0.83. How much space I have? Okay. So this cancels out. I get 0.04n equals 212. And then I divide by 0.04. I'm going to do this on my calculator. So I have, let's see, what did I say? 212 divided by 4/10 or 4/100 actually, sorry, is going to be 53. So again, when you get to the end of a problem, I don't know about you, maybe it's just because I'm old, but when I get to the end of the problem sometimes I'm like, n is 53, that's great. I have no memory of what I was talking about, like 53 what? So think back, we're talking about the pennies and the nickels, so n is 53 nickels, okay? Nickels, also notice the spelling, it's E-L-S, not L-E-S, not like pickle. So 53 nickels. So now I want to know how many pennies there are. Well, I can use my equation, which was P plus N equals 83. Again, you might be able to do this on your own, in your head, and that's fine. We want to just kind of see the process for when the numbers are harder. So subtract 53, P equals 30. So that's 30 pennies. Okay, so now we really want to check this. So first of all, we want 83 coins, right? That's one of our things that the problem said. Well, 30 plus 53, yes, that is 83, so that's good. Okay, the other thing we wanted is we wanted them to add up to 295. So nickels, if I have 53 nickels and I multiply that by 5 cents each, right, because each nickel is going to be 5 cents. So 53 times 0.05 is going to be $2.65. Okay, and then I have 30 pennies. Well, even without multiplying that in a calculator, if you have 30 pennies, what do you have? Well, you have 30 cents. And then if you add those together, you do get your 295. So that does check. Okay. And as I said in class, think about this as sort of on the scale. If we had all pennies, we'd only have 83 cents. If we had all nickels, we'd have a much larger number, right? So we are in the middle there. And 31 pennies and 52 nickels is going to have a different answer. And 27 pennies and 56 nickels is going to have a different answer. Okay. So we want to make sure that our answers check. And they check in both equations. Or in both, scenarios there. Okay, let's move on to the next two. And we did something similar to these in both classes. These are the Pythagorean theorem questions. You can see a ladder is leaning against a building. And again, we went through this in class that in real life, the building and the ground are really not going to be at a right angle, but in these problems, we always assume that they are, just for simplicity. So the ladder is 40 feet long. The base of the ladder is 15 feet from the building. Here's where we're assuming it's a right angle. How far up the building does the ladder reach, right? So what's the distance from there to there? Because remember, again, that if you have a 40-foot ladder, it's not going to reach 40 feet up the building unless you have it flat against the building, in which case it's not very safe and it's going to fall over, right? You have to kick the bottom out to make it stable. So that means it's not going to be all the way up to 40 feet. So I'm just going to rewrite my little triangle here now that I kind of understand how it's oriented. So this is 15 feet, this is 40 feet, this is x, or x feet if you want to put that. Okay, so this is going to be quick because again, we did this in class, in both classes. A squared plus b squared equals c squared. Remember that your legs, which make the L, which make the right angle, those are either A or B, regardless of what we know and don't know. Hypotenuse is always C. All right, so X and 15 are my legs. Now, let's say I'm going to have X, that unknown side, be in for A. I can either say A squared or I could say X squared. It doesn't really matter. It's just a variable, right? So we can call it either one. We don't know what it is. Plus 15 squared equals 40 squared. So let's go ahead and square these. This is going to be 225, and that will be 1600. Okay, so all I did so far is just square those two numbers. And so now I want to move things around to get A by itself. So I'm going to subtract 225. A squared equals, and then 1600 minus 225 is going to give me 1375. And then I'm going to take the square root. So I'm going to take the square root of a squared and the square root of 1375. And on the left-hand side, that is going to cancel out the square and the square root. So I'm going to have a equals, and then I'm going to take the square root of, oops, hang on 1 second here to clear that. All right, so I'm going to take the square root of 1375, and I get a really long decimal, right? I get 37.080992435 dot dot dot. So that's okay. Remember that because well, you have two choices when you're taking a square root. Either the number under the square root is a perfect square and you'll get an integer, or the number under the square root is not a perfect square and you get an irrational number, a decimal that goes on forever without repeating. So you will never get, when you take the square root of a number, you'll never get something like 4.75, right? It's going to, you might round it to that if that's what it asks you to do, but it's either going to be an integer like 8, or it's going to be a number that goes on forever. So notice up here it said round to the nearest tenth of a foot if necessary. So if necessary means if it's an irrational number, which it is. So here is my tenths place, the 0. So I look next door. If the next door number is 5 or above, it makes this underlined number go up, which in this case it is. So I'm going to have a equals 37.1 feet. That's about how high the ladder will reach. Okay, so pretty close, but also it's a very big ladder to have still that close to vertical, right? Kind of want to kick that out a little more probably, but I don't know. I'm not a carpenter, so just be careful on ladders. That's my advice. All right, so 37.1 feet. Okay, go ahead and try number 4, please. I'm actually going to pause the video and do it, so when I want you to pause it, and then it'll be just kind of done there when you start the video again, and you can check your work. Okay, so the most important thing I think with these is to draw a picture. Once you draw a picture, you might not see it right away and notice it's the Pythagorean theorem problem, but when you have something like this where you want to, there's a ramp or a ladder or whatever it is, draw a picture. Once you draw a picture, that will help you figure out what you want to do. Okay, so go ahead and pause the video and try number 4, please. Okay, so I have this mostly done except for the last step or two. So here's my little picture, okay? I have a doorway. If in a building you see a doorway that's up a little bit, it's only 2 feet, but there are stairs. There used to be stairs there, maybe. They want to take the stairs, the stairs are away. They want a ramp right here. So the ramp is 2 feet tall, and they want it to start 6 feet away from the building. So from the doorway to the end of the ramp is going to be 6 feet, and want to know how long the ramp will be. So the length of the ramp is going to be where the X is over here on this little, I just pulled the triangle out. So I labeled everything, and then we noticed that there's an X over here on the hypotenuse this time, right? And these are the legs. Okay, so 2 and 6 are going to be A and B. They can be in either order. Because when you think about it, I have 4 plus 36. If I had them the other way, I'd have 36 plus 4. Same thing. So I plugged in for A and B. My C is my unknown. So I don't know. Here I switched it to say x squared instead of c squared. Last time I left it as the A. It really doesn't matter what variable you use there. So I square both on the left. It's a little different now because I just have numbers on the left, no variable. So I square both of those. Add them, x squared equals 40. So I stopped here because I want you to think about what kind of an answer we're going to get, right? Think about if 40 is a perfect square. If you're not sure, think about your perfect squares, like your multiplication facts. So 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. So when you think about all of those, I will tell you that 40 is not a perfect square because 6 times 6 is 36 and 7 times 7 is 49. So it's going to be a number between 6 and 7. So let's take the square root of both sides. And when I take the square root of both sides on my calculator, let's see, square root of 40 is, so this is going to be x, I'm just going to write it the other way so I have more space, is going to be 6.324555323. blah, 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 okay? Now, in this case, I was bad and I didn't tell you what to round to. So you can kind of choose, you know, if that happens, just show me what you did, right? So if you're going to round to the nearest 10th, then I want to just see, okay, that you rounded to the nearest 10th, right? So this is feet. Okay, now maybe you've noticed by now also that the hypotenuse is always larger than either of the legs. Okay, not the two of them together, but like here, the hypotenuse, I knew it was going to be more than 6 because that's what the leg is. So even if it's a tiny bit more, if it were exactly the same size, it would match up. It wouldn't be opened up at all, right? So since it's opened up, it has to be a little bit longer. All right, so that's our Pythagorean theorem problems. Okay, so now we have, let me just look and see how many, a few 5 problems that are either equations or inequalities. So again, writing these equations, and some are equations, some are inequalities. So let's just talk about that for a minute. So if it says something like this, if it says 3 more than a number is 20, okay? Well, let's think about what we know about special words in here. We know here's is. And if we read this, it's a statement, it's a declaration saying 3 more than a number is 20. No questions, right? No anything else, just it is 20. So there's my equals. I'm going to have 20 over here. 3 more than means to add it. So 3 more than a number. So 3 plus x equals 20. Now, let's see. Let me give you one that's really similar. 3 times a number is more than 20. Okay, so now the difference here is that it's not saying 3 times a number is more than, or it's not saying 3 more than a number is 20. It's saying 3 times a number in this case is more than 20. So it's not that something is 20. The statement here, the fact or the statement is that the left side is more than the right side, not equal to. Okay, so there's the difference. Even though they both have more than, one of them is blah, blah, blah is this. The other one is blah, blah, blah is more than this. Okay, so 3 times a number, 3x, is more than 20. That's where I'm going to have an inequality sign. So you kind of have to be careful about which we're seeing, okay? And we're never going to have both in the same problem. So you're not going to have, sometimes people try to put both in there, like they would say 3 greater than x equals 20. Nope, it's got to be one or the other. So this is, right, there's my is more than. And over here, this equals is my is. So just keep an eye on, that's just one example, right? It could be less than, whatever, but just keep an eye on those. Okay, so let's look at the first one. 5 more than a number is 12. Look at how it says is. So that's going to be equals, it's going to be equals 12, 5 more than a number. Obviously for this one, to solve it, we just subtract 5, x is going to be 7. Okay, let's look at the next one. 5 more than a number is more than 12. That's a red flag there. That's going to be an inequality. So it's more than 12. So 5 more than a number is more than 12. So if you need to take a minute or two with that, you can pause the video, kind of think about that one. Okay. Twice. So first of all, don't panic. Okay, let's just read through it a few times. Don't even have your pencil in your hand right now. Just let's read through it a few times first. So twice the sum of a number and 8 is at least 3 times the number. So let's just start with where the equals or inequality is. Blah, 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 blah. It doesn't say it is. It says it's at least something else. So that tells me that this is going to be an inequality, because it's not that this thing is exactly like this, it's that it's at least. So let's think about at least for a minute. So let's say you say, I want to get at least an 80 on this test. Okay, so if you say this, you say you want to have at least an 80, what does that mean you'll be happy with? Well, if you want at least an 80, you'll be happy with an 80, you'll be happy with an 81, you'll be happy with an 82, etc. Right? So at least means that number or bigger. So greater than or equal to. So just think about that for a minute, and you can think about, again, times you use this in your own life, right? I want you to give me at least 3 cookies. Well, I'll be happy with 3, but I also will be happy with 4 or 5 or 12 or 27. Okay, so now that we've gotten that kind of set, so this is at least as much as this. It's either greater than or equal to. So twice the sum. Remember how we did this? So twice the sum. Now when you see sum, you have to look for and. The sum of a number and 8. So that tells me that a number and 8 are the 2 things being added. So this is a sum. 2 things are being added. Here are these 2 numbers. The and is where the plus sign goes. So x plus 8, twice the sum of that, is at least 3 times the number. So twice the sum of a number and 8 is at least greater than or equal to 3 times the number. Okay, I'm going to pause it and finish the solving. I want you to pause and finish the solving, and then you can come back and check your answer. Okay, so hopefully you paused the video, solved it. Don't get, kind of stressed out about this right-hand side when the 3 x's cancel here. Sometimes people try to move this over. We don't want to do that. 3x minus 3x gives us 0, and 0 is a perfectly nice number. So just go ahead with that. Subtract the 6's. The way I did it, since I moved things to the left, I ended up with a negative x. Negative x is greater than or equal to negative 6. I have to divide by negative 1, which is really what's in front of that x. As soon as I hear myself saying that I'm dividing by negative 1, I'm going to flip the signs. So x is less than or equal to 6. So what this means is if I pick any number less than or equal to 6 and substitute it in for here, then twice the sum of that number and 8 will be at least 3 times the number. So it'll be greater than 3 times the number or equal. So if I put 5, for example, 5 plus 8 is 13. So I'm looking up at this original equation now. 5 plus 8 is 13. 13 times 2 is 26. 5 on the right hand would be 15. So that's not a proof, but that's just one example showing how it works. Okay, so there are 2 more examples here. Don't worry about these boxes. I've kind of done some of the wording differently sometimes, some semesters. But we're going to do 8 and 9. Again, I'm going to just pause my recording and do them, and then I want you to pause them, and then you can come check the answers. Okay, so here's the rest of that one. 5 times a number is no more than, that means less than or equal to, the number plus 8. I subtracted x from both sides, solved, x is less than or equal to 2. So that means if I choose anything less than or equal to 2 to be an x, then this is going to be true. If it's more than 2, it's not going to be true. So let's say I pick 1. This would give me 5 on the left-hand side. So 5 less than or equal to 9, which is true. Now, with an inequality, we can't check all of them, right? We can't possibly check everything in the world that's below or equal to 2. But sometimes I like to just pick one on either side. So let's say I had 10 instead. And 10 obviously is not in our solution. Our solution says it has to be less than or equal to 2. So 5 times 10 over here and 10 plus 8 over here. Well, I get 50 less than or equal to 18. Obviously that can't work, right? So that does help us show that anything, in that range doesn't show exactly, but we've tested one thing on the side that shouldn't work and one thing on the side that should. Okay, last one, difference. This is an important word to remember. Twice is greater than, so the difference between a number and 3, that's subtracting, is greater than, pretty self-explanatory, twice the number. So I have x plus 3 greater than, 2x. Subtract x from both sides, I get negative 3 is greater than x. Now normally I don't like to have my x on the right, but since there was no other term on the left, I just decided to. Remember that you can write these either way. So negative 3 being bigger than x also means that x is smaller than negative 3. Okay, so that is the end of the notes. Again, don't worry about those box things. So that's the end of the notes. Please, when you're done looking over this, or as you're looking over it, jot down any questions you might have and bring them to me either in office hours or during class. All right, thanks guys.